Hi everyone, welcome to this course Electric Circuit Theory. We'll start with part 3 of chapter 1, that is network analysis. We'll start with nodal analysis. Nodal analysis is also referred to as node voltage method, and it is the method of circuit analysis which is used to determine the values of voltages at all the principal nodes with respect to the reference node. After the determination of the node voltages, the currents flowing in each branch can also be determined. In nodal analysis, KCL, Kirchhoff's current law KCL is applied to each node and simultaneous equations are formed whose solution gives node voltages with respect to the reference node. We'll first start with the first problem of this nodal analysis. And here we are given the problem. And here we have been asked to compute the current through each resistor using nodal analysis in the circuit shown in the figure below. So in order to solve the circuit using nodal analysis, we have to assume the nodes. In this circuit, we can easily see that there are 4 nodes. There's one node, second node, third node, and there's a fourth node. So out of these 4 nodes, one node is considered as a reference node, and the remaining nodes are considered as V1, V2, and V3, as shown in the figure here. So for nodal analysis, we have to apply KCL at each node. And in this circuit, we can see that there's a voltage source connected between node V1 and V2. That's why we have to consider a super node consisting of nodes V1 and V2. So when we consider a super node consisting of node 1 and node 2, this voltage source is neglected. And after neglecting this voltage source, we can easily see that there are 4 more branches. This branch and this branch that is connected to node 1, and this branch and this branch are connected to node 2. So we will we'll find the current through each of these branches. And for KCL, we know we'll be equating incoming current and the outgoing current. So since there is no current source connected with either node 1 or node 2, that's why all the currents are assumed to be outgoing currents. So when all the currents are assumed to be outgoing currents, this equation will be obtained. V1 minus 20 divided by 5, this obtained from this branch. V1 minus 20 divided by 5. And the other is V1 minus V3 minus 10 divided by 3. And for this branch, V1 minus V3 divided by 10, this is the equation. And V1 minus 0 divided by 1, this for this branch. In this way, the KCL has been applied at super node consisting of node 1 and node 2. After simplification, we can get the equation 1. Now, since there is a voltage source connected between node 1 and node 2, the node voltage is V1 at the positive terminal of this voltage source, and node voltage is V2 at the negative terminal of the voltage source. So we can easily write V1 minus V2 divided by 15. This gives equation 2. Now, we can see that there's a voltage source connected between node V3 and the reference node. So here also we can easily write V3 minus 0 equals to 3ix1. Since V3 is connected to positive terminal of the source and 0 reference node is connected to the negative terminal of the source. So we can easily write V3 equals to 3ix. But in this case, since this is dependent source, the value of this source depends on the current. Okay, this is current dependent voltage source. So since the value of this voltage source depends on current Ix, we have to replace this Ix in terms of either V1, V2, V3 or combination of these. So in this case, we know Ix equals to V1 minus 10 minus V3 divided by 3. So we'll be replacing Ix by this expression. So if we plug in this value of expression of Ix in this equation, we can obtain this equation. So in this way, equation 3 is obtained. So now if we solve equation 1, 2, and 3, we can easily get the values of V1, V2, and V3. So After obtaining the values of V1, V2 and V3, we can easily compute the current through each resistors. For example, in order to compute the current through resistor 1 ohm, we can simply write V2 minus 0 divided by 1. Okay. And for 3 ohm resistor, V1 minus 10 minus V3 divided by 3 ohm. And for this 5 ohm resistor, the current can be either V1 minus 20 or 20 minus V1. But in this case, since the value of voltage V1 is less than 20, that's why I have considered 20 minus V1 divided by 5. In order to make, this is simply in order to make the value of current positive. Okay. We can also write V1 minus 20 divided by 5, but the value of current will be negative. It doesn't matter. Only the direction, the assumed direction will be opposite. So it doesn't matter. And finally, the current through 10 ohm resistor can be computed in this way. V3 minus V2 divided by 10, or you can even compute this using V2 minus V3 divided by 10. Okay, only the direction will matter. Now let's start with another problem. In this problem, we have been asked to compute the value of voltage source Vs. Okay, this voltage source Vs for the circuit shown in the figure below for this circuit. And the other information given here is that the current through 3 ohm resistor is 6.76 ampere and the direction of current is also given. So in order to solve this circuit using nodal analysis, we'll start by finding the nodes. In this circuit, similar to the previous circuit, there are 4 nodes, this one node, this second node, third node, and this fourth node. One of the nodes is considered as a reference node, and the remaining 3 nodes are named as V1, V2, and V3 as shown in the figure. So now we'll start by applying KCL at first node. In order to apply KCL at node V1, we can easily see that the 3 ampere current is also outgoing. The 6.76 ampere is also outgoing. So, and for this branch as well, we'll assume the outgoing current. So if we do so, all the 3 branch currents are outgoing. So the outgoing current through this branch is V1 minus Vs divided by 5. Outgoing current through this branch is 3 ampere, and the outgoing current through this branch is 6.76 ampere. So we can write this equation. From this, we obtain the equation 1 in terms of Vs and V1. Now we'll apply KCL at node 3. In order to apply KCL at node 3, we can easily see that 6.76 ampere current is incoming to node V3, 10 ampere is outgoing, and we will assume this current and the current through this branch as well outgoing. That's why we obtain this equation. 6.76 is the incoming current, 10 ampere is the outgoing current, and V3 minus V2 divided by 10 is also outgoing current. After simplification, this results in equation 2. Now let's apply KCL at node 2. When we apply KCL at node 2, this 3 ampere current is incoming current, and we'll assume the outgoing current at this branch and this branch. So we obtain this equation. 3 ampere incoming current, V2 minus V3 divided by 10 is outgoing current here, and V2 minus 0 divided by 1, this is also outgoing current. After simplification, this results in equation number 3. Here we can see that if we solve equation 2 and 3, we can obtain the values of V2 and V3. And after obtaining the values of V2 and V3, we can write that V1 minus V3 divided by 5 equals 6.67. This is obtained from this branch. In this branch, we can easily see that V1 minus V3 divided by total resistance, that's 5 ohm. It's equal to 6.7. It's a given information. Using this given information, we can calculate the values of V1. So if we calculate the values of V1, then finally, we can substitute the values of V1 in equation 1 to obtain the value of Vs. In this way, we can finally compute the value of Vs. Thank you.